Queuing. Okay, so here is a queuing time plot, and we've got times that people arrived. Okay, not the exact time, but we started in our survey and then we counted each minute. Okay, and so A and B arrived at 0 minutes. This is the in queue column, and this is the server column. So when A and B arrived at the same time, A got served straight away, and because A was being served, B had to wait in queue until A was finished. And then when A finishes, B drops in. Okay, and once B finishes, then, okay, we can see that C and D arrived. C left because he saw the length of the queue and went, nah, see you later. But D waited until B was finished, and now it's D in where B is. Okay, so that's our queuing time plot, and we're going to turn it into a graphical form here. Okay, so first off, we need two colors. Okay, and we're going to write down A and B both arrived at 0 minutes. A and B. Okay, now A got served straight away for 2 minutes, so we're going to color in 2 minutes. Okay, B had to wait until A was finished, so we draw a line to say he's in the queue. Now B was served for 3 minutes, so I'm now going to hatch in 1, 2, 3 minutes. Okay, and then he left. C arrived at the 1 minute mark. Okay, but saw the queue and decided to leave, so I'll put a little cross there. D arrived at the same time, and he waited in queue until B was finished, so we'll draw a big line here. Okay, and D was served for 2 minutes. E arrived at the 6 minute mark, so E arrived here. Okay, and we can see that E only had to queue for 1 minute because D finished then, and then E was served for 1 minute. Now we've got a bit of free time, okay, because no one turns up until the 10-minute mark, and we're finished here, so there's going to be a block of free time for the server. So 10-minute mark, F turns up, 10-minute mark, okay, F gets served straight away because there's no one there, and he gets served for 2 minutes. G turns up at the 12-minute mark, okay, and G gets served for 3 minutes. 1, 2, 3. And now we've got H turning up at the 13-minute mark. Okay, H has to wait until G's done, and then H gets served, and our survey finishes. Okay, so we don't know how long H was served for. So now that we've got our graphical form, we can easily work out things like inter-arrival time. Okay, inter-arrival time. So inter means between, so we're looking at the time between arrivals. So time between A and B arriving was 0. B and C arriving was 1. C and D arriving was 0. D and E arriving was 1, 2, 3, 4, 5. E and F arriving was 1, 2, 3, 4. 2 minutes here, 1 minute there. Okay, and we're going to do an average. So we're going to add all of those up and divide it by 1, 2, 3, 4, 5, 6, 7. Okay, so we've got 5 and 5 and 3. It's going to be 13 on 7. Okay, which is, let's do it properly, 7 and 1 zeros, 13 is 1.8 minutes. Right? So that's inter-arrival time, okay, our average inter-arrival time here. Next up is average service time. Okay, now this one's easy as well. We just take our, slide that up, okay, service time. So we look at the blocks of red service time. So we've got 2 minutes, okay, plus 3, plus nothing for C, plus 2, okay, plus 1, plus 2, plus 3. Now, we don't know how long H was being served for, okay, because our survey ended at the 16-minute mark. So it's probably not fair to include him in an average of service time if we're trying to work out the average service time, because we can't say. Maybe he was there for 20 minutes being served. Okay, so we're going to make a call and an assumption, and I would write that, and I would put a little comment, a little sentence off to the side explaining our methodology of removing H. Okay, so there's H, and H is gone. Okay, so now we're just going to do that 1, 2, 3, 4, 5, 6. Average that. Okay, so you got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, it's now 13 on 6. Okay, 13 divided by 6 is going to be twice with, okay, if we, yep, so 2.1 minutes. Okay, average service time 2.1 minutes. Okay, next one is average time in queue. So I'm going to go over here, okay, and we're going to put time in queue, okay, and I've got, what have I got? 0 minutes here for A, okay. It's important to add the 0 in, even though we didn't wait in the queue, because if you just added the people who actually did queue, then you're going to get a skewed idea of what your average time in the queue is. Okay, you're going to think that everyone has to queue for this amount of time, when in actual fact, 3 of the people that we served, that we were there, didn't have to wait. Okay, so you're going to make sure you put these zeros in. So now I've got 0 plus, and here's 2 minutes in the queue. Okay, should we count C? C didn't really join the queue. He saw the queue and left. So we're not going to count C. We might put a little thing there to say, write a sentence about C. Okay. We've got 1, 2, 3, 4 here. 1 there. 0 minutes here for this person. 0 again. And 2 minutes for H. Okay. 1, 2, 3, 4, 5, 6, 7. Okay, let's do that. 4, 5, 6, 7, 8, 9. It's going to be 9, 7. Okay, 9 divided by 7 is going to be 1 point. Okay, so it's going to be 2 with a few remainder, 6. Okay, so it's going to be 8, so 1.28 minutes. Okay. And then these really quick ones, maximum backlog is the maximum number of people in the queue at the same time. Okay, so we can see here the maximum backlog was, okay, 1, 2, B, C, and D. Oh, let's go back to the table. We can see it easier. You can see that B, C, and D in the queue. Okay, so our maximum backlog was 3. Our longest wait, well, that's really easy to see from the graph. Who had the longest wait time? Well, that was D of 4 minutes. Okay, let's write down D, 4 minutes. Okay, and then the server free time was between 8-minute mark and 10-minute mark. 8 to 10 minutes. Okay, now all of these things can contribute to us making a call on whether our queue is effective or not, and whether we need to put a second server on. Okay, so this looks like a pretty healthy queue because, okay, in the longest wait is 4 minutes. Okay, the average wait, okay, in the queue is 1.28 minutes, which is like negligible. It's pretty good. Okay, and we can see that the server's only free for a short amount of time. He's not sitting there waiting, doing nothing. Okay, we're paying that person, so we want them to be doing something. Okay. And we can see that the service time is pretty good too, like 2 minutes to serve each person. Okay, is pretty good when you've got an inter-arrival time of 1.8 minutes. So people are arriving on average less than the time it takes to serve, okay, which would normally generate a queue, but 1.8 to 2.1 minutes is pretty similar, okay, and because it's an average, pretty similar might mean that sometimes you get a queue, sometimes you don't.